So looking at the week, today is April 18th. We have basically 2 weeks of review left, and then we start AP testing. So I'm not really going to review on the week of May 2nd. 2 videos are assigned, and you can watch those at home or in class or however you want to do that. But because so many of y'all are in government, APES, let's see, literature, that's the senior one, isn't it? So I bet some of you are in that. APUSH, that's junior year. Anyway, you guys are going to be in and out all that week. And so I'm not doing anything like curriculum or even review-wise. That's when we'll start the project. So we got 2 weeks to review left. This week, I'm going to change up the order of things. We're going to start with FRQ5 today, and we'll review the test on Tuesday and block day. That gives those of you that still need to finish the test, I hope you do that today, and then we'll go over it Tuesday and Wednesday. It also gets us started a little earlier on the packet for the week. That way you will have seen the stuff and you can start working on it, kind of whenever. It'll be due Monday. It's one topic. It's a free response set and a multiple choice set, but it's the same topic. So I've matched them up. So it's, again, sort of 2 days worth of worksheets, but it's only one topic. It's only 2 days worth of worksheet, even though we have 5 days this week, because 2 of the days we'll be reviewing the test, one kind of a catch-up day. And because it's a little light on the assignment this week, I put 2 videos on this week. So review video 4 and 5, it's in AP Classroom waiting for you. The review or the worksheet that I'm going to hand out and we'll start today. And again, we'll review the test Tuesday and Wednesday. Where did my picture-in-picture go? There we go. Again, it's the same topic, differential equations. So if you get motivated and you want to start multiple choice, that's fine. It's the same topic. They're just multiple choice questions. All right, this first question is kind of every I don't know, 3, 4, 5, 6 years, one of the multiple or free response questions is so students think it's so difficult that it becomes sort of famous in calculus teacher world. And the potato problem achieved that status nearly immediately. Students came out complaining about the potato problem. After it was released, calculus Twitter, there is such a thing, and Facebook was all about the potato problem. So we'll do the potato problem together, 2017, so that wasn't that long ago. And what else was I say? Again, the BC stuff, again, I only picked the test or the problems that would appear on both because there is overlap on those. All right, so the potato problem. A boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time equals 0. Let's see, so it's using H and peeking ahead for the temperature. So at time 0, the temperature is 91. The internal temperature of the potato is greater than 27 for all times greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function that satisfies the differential equation. Okay, so it's giving us the derivative, it's giving us the rate. We'll have to underivative that. We'll have to integrate that to get back to temperature, where H is measured in degrees Celsius and H of 0 is 91. Okay, so it starts at 91. We already have that. Write an equation for the line tangent to the graph. Okay, so already I'm thinking tangent line means I need a slope and a point. At t equals 0. So my point will be 0, 91. Use this equation to approximate the internal temperature of the potato at time 3. Okay, so I need to do two things. Write the tangent line and then use the tangent line to approximate the temperature. So I need the slope, the dy dx, or I guess in this case the dH dt, at time equals 0. So how am I going to find the slope at time equals 0? How can I do that? Okay, so plug in. I like that because I have an expression for dH dt. But what am I plugging in? 91. So be careful. I'm not plugging in 0 because when t is 0, h is 91. So that's a little bit tricky. 91 needs to go there. I guess I could just leave all that as is, as my slope. But I'm going to have to do something with this later. So I think I want to simplify this. 91 minus 27. This is the no calculator one, so if I'm doing this, I better be careful. 64. 64 divided by 4 is 16. So my slope is negative 16. Again, you could have left all of this as is, and maybe that would be wiser, but I know I'm going to use it in a minute. So y, or I guess h, minus 91 equals negative 16 times t minus 0. That's my tangent line. Use this equation to approximate the internal temperature when t equals 3. So when t equals 3, h equals negative 16 times 3 minus 0 plus 91. Hey, this is the end of the problem, so I'm not simplifying that. I'm going to leave that alone and leave it as is. 91 minus 48 would be 43. If I wanted to check and see that my answer made sense. Right? Because the potato's cooling, so it should definitely be less than 91. How much less than 91 3 minutes later? I don't know. Part B. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. Okay, well, I'm not sure about the under-overestimate thing, but I can at least find a second derivative, and I would bet just about anything that part of the points for this is finding the second derivative, and the other part of the points is getting the over or underestimate correct. So let's see, a second derivative. You know what, maybe it would be easier if I wrote it negative 1/4 h plus 27 over 4. So it's a little bit clearer that the 27 over 4 is going to go away in this one. So the derivative of h, how do I take the derivative of h? So I'm going to take the derivative of everybody to get my... It's not just negative 1/4 because it's derivative with respect to t. So that's a good question. If it was the derivative with respect to h, the h would go away and you'd get negative 1/4. But since it's respect to t, it's just going to be negative 1/4 dH dt. Which maybe seems strange, but I have an expression for dH dt. So negative 1/4 times negative 1/4 times h minus 27. So my second derivative then is 1/16 h minus 27. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. Okay, so there's my second derivative. What about positives and negatives? So is the second derivative positive or negative at time equals 3? Right, because that will help me with concavity and over and under stuff. Let's see, at 3, the temperature was 43. At 0 is 91. In fact, they said that H was always greater than 27. Now I know why they said that. H, so the second derivative then is always positive. So if the second derivative is positive, what does that tell me about H? Is concave up? So I know we're concave up, but there's two ways to be concave up. Right? I can be concave up increasing, or I could be concave up decreasing. Which one are we doing here? Is H increasing or decreasing? It's decreasing because we took it out of the oven and now it's cooling down. So I need H to be decreasing but concave up. So something like that. And that looks like a temperature would, like immediately it's cooling quicker, and as it gets closer to room temperature it doesn't cool as fast. So we used a tangent line approximation So is our approximation H of 3 approximately was 43 is an overestimate or an underestimate based on my picture? Is an underestimate. And there's all my reasoning. Now, even if you weren't sure about the overestimate, underestimate stuff, I would hope you could get the second derivative, at least the first part of that question. Question C, for part C. For T greater than 10, an alternate model for the internal temperature of the potato at time T is the function that satisfies the differential equation. Okay, so when T is greater than 10, we're switching to a new model here. Where G is measured in degrees, and G of 0 is 91. So that's the same starting point. Find an expression for G of T. Okay, so I got to go backwards from a derivative, so I'll need to integrate. Based on this model, what is the internal temperature of the potato at time equals 3? Okay, I kind of don't like this question because they said for T greater than 10, use this, and then they ask a question about T equals 3. So that's a little bit misleading, but it does say based on this model, so we'll use G to come up with G of 3. Okay, so I need to solve for G, use my initial condition, and then plug in 3. So I bet there's a lot of points associated with part C here. Let's see. So I need to separate those variables, get all the G's on one side, all the T's on the other side. So dG over G minus 27 to the 2/3 equals negative dt. And I think I'm going to rewrite this as G minus 27 to the negative 2/3. Negative sign could go on either side. Doesn't matter. We'll integrate to undo the derivative. So, let's see. I could do a u substitution here, but it would just be g minus 27. du would be dg, and so I don't know that that's really necessary. Sorry, my 6's and g's look alike here. Increase the power by 1. So that would give me 1/3. Divide by the new power, so times 3. And I'm going to put the plus c on the other side. It doesn't matter, but it seems like it'd be easier to handle on the other side. Negative t plus c. All right, some people will solve for c here and then get g by itself. Other people will get g by itself and then solve for c. Doesn't matter. I think I want to get g by itself and then solve for c. So g minus 27 to the 1/3 equals 1/3 times negative t plus c. And then if I cube both sides, g minus 27 equals, I'm trying to think if there's a better way to write this, c minus t over 3 cubed. So g equals c minus t over 3 cubed plus 27. And g of 0 equals 91, so I can figure out what c is. Alright, so let's plug in 0 for t, and g would be 91. So 91 minus 27 is, we did this already, 64. Oh, they were kind to us. Because if I cube root 64, what's the cube root of 64? 4. I don't have a calculator, but they kind of rigged this problem for us. So all that to say, c equals 12. So g equals 12 minus t over 3 cubed plus 27. And we're not done yet. That's find an expression for g, so there's probably most of the points. Based on this model, what's the internal temperature at time equals 3? So 12 minus 3 over 3 cubed plus 27. I'm tired of this problem. That's a safe stop. You figure it out if you want to. Now, if we did want to, 9 divided by 3 is 3. 3 cubed is 27. 27 plus 27 is 54. Our earlier guess was 43, so 54 is sort of in the ballpark, so I feel okay about that answer. And that's why that was a immediately gained legendary status as a AP question, the potato problem. But the big deal was, well, first we had to take a derivative that threw in an extra derivative. That happens a lot. And then we had to integrate to get back to the original. Let's do question 2. We got 15 minutes left, but that's how long it should take. Still no calculator. Response number 5. Question number 2. Consider the differential equation dy dx equals x squared minus 1/2 y. Okay. I guess I like that it's not a potato problem, or just a straightforward problem here. Find the second derivative. So I need to take the derivative of both sides with respect to x to get the second derivative. So what's the derivative of x squared? 2x. What's the derivative of minus 1/2 y? Yeah, minus 1/2 y dy dx. But I reread the question and it says find the second derivative in terms of x and y. So how do I do that? Because this is not in terms of x and y right now. It's in terms of x and dy dx. But we know dy dx, so I'm just going to replace that with dy dx. So 2x minus 1/2 x squared minus 1/2 y. And maybe that could be cleaned up. Maybe there's like terms. There's not, but I could distribute. I don't want to mess with that. I'm done with part A. Moving on. If I need to clean it up for something later, I will, but right now I'm good with that. Part B. Let y equals f of x be the particular solution to the given differential equation whose graph passes through the point -2, 8. Does the graph of f have a relative minimum, relative maximum, or neither at -2, 8? So what would be happening at a relative min or relative max? Okay, the change in the sign of f prime. That's true. What else? How else could we say that? Because the way you phrase that is true but not helpful for this particular problem. The slope is 0. So let's start with there. Let's start with that, and then if that's true, then we'll have to do something else to figure out if it's a max or a min. Well, I have a slope. I have dy dx, x squared minus 1/2 y, and I want to evaluate that at -2, 8. So I'll know the slope at -2, 8. I haven't worked this problem yet, but I'm guessing we're going to get 0, and then we're going to have to do something else to figure out if it's a min or a max. Because the problem would be over if it's not 0. So 4 minus 1/2, 8, yep, is 0. So it's, well, actually, I still don't know if it's a min or a max, because you could have that situation where this goes on. So first derivative is 0, so I might have a min or a max. One way to tell is the first derivative test, where you do a number line, and let's see, this was at -2, 8, and we know f prime is 0 there, and so we'd want to see if it changes positive to negative or negative to positive. But that won't work for this problem, because the first derivative has x's and y's in it, and so I can pick x equals -1 or -3 and -1, but I don't know what y is. So this method is not going to be useful for this problem. Now, they did ask for the second derivative. How can a second derivative help me figure out if something's a max or a min? The concavity, right? If it's concave up, then that means it's a min. If it's concave down, that means it's a max. This is the first derivative test. which, I mean, it's great, but it doesn't work for this problem. This is the second derivative test, but now I understand why they asked for the second derivative. So the second derivative at negative 2, 8. So 2 times negative 2 minus 1/2. Negative 2 squared is 4 minus 1/2 of 8. Oh, well, the second part is 0. That's because it was the first derivative. So the second derivative is negative 4. So if y prime equals 0, y double prime is negative. That means negative 2, 8. So let me see. Second derivative negative means concave down. I mean, you don't have to write all this out, but this is sort of me convincing myself here. Concave down at a flat spot, we've got a relative max. Based on the second derivative test. Yes, sir.
If you were to write like it's just a maximum and not a relative maximum, what would the problem be counted for it?
Let's see. How did it phrase that? Does it have a relative max, a relative min, or neither? Ooh, that's a good question. I don't know if they would accept just max. I bet they would, because all of your work supports that, but I'm not sure. That's when we're rereading the question and realizing they put relative on there, so you should probably put relative on there as well. Part C. Let y equals g of x be the particular solution to the given differential equation. So same differential equation, but now g of x is our answer. So like someone was able to integrate this. We do not have the ability to do that. G of negative 1 equals 2. Find the limit as x approaches negative 1, g of x minus 2 over 3 times x plus 1 squared. A limit on a free response question, L'Hopital is almost certainly going to be involved here. Let's see. So if g of negative 1, if I try just good old-fashioned substitution first, let's see, the top would go to 0 because you'd have 2 minus 2 equals 0, and the bottom would go to 0. And so this came up again on the Facebook page of what do you write to be clear that you're using L'Hopital. And one of the things they emphasize several times is, and I don't know that I emphasize this enough, do not write equals 0 over 0, because it doesn't equal 0 over 0, because 0 over 0 is indeterminate. So I've carefully avoided not writing equals 0 over 0. I have 0 over 0 written down, but I haven't said that this limit is equal to 0 over 0, because that would not be true. So you just kind of be careful. What I do want to say is 0 over 0 is an indeterminate form. So that picks up, we did say you need to say that. So the only thing I added is just be careful not to say that the limit equals 0 over 0, because that's not technically correct. Therefore, let's use L'Hopital's. So g prime of x over derivative of the bottom would be 6 times x plus 1 to the first. I think it was the most recent test before the practice test. We had a L'Hopital's, I think the bonus was kind of like this. And in fact, I've got 0 in the bottom again. So I'm careful. I'm not going to put equals 0 over 0, but I'm worried that that's where we're going. g prime of 1 equals, so that's the first derivative, but I have an expression for the first derivative. 1 squared minus 1/2 of y, but when x is negative 1, y is 2. So sure enough, we get 0 over 0 again. That's still an indeterminate form. Therefore, we'll use L'Hopital's one more time. Limit as x approaches negative 1 of the second derivative. And this time, let's see, the bottom would just be 6. So, not going to be indeterminate this time. I don't know what's happening, but the bottom is 6. At the top, the second derivative at negative 1. Did we find that already? Or do we need to... We have the second derivative, but I don't think we found it at negative 1. So go way back up there. Second derivative was 2x minus 1/2 x squared minus 1/2 y. And we want to evaluate at negative 1, 2. This time I'm paying a little closer attention, and I realize that second part is 0 because that's the first derivative. So 2 times negative 1 is negative 2. So my answer is negative 2/6. Sure, it reduces, but hey, that's your problem, grader, if you want to reduce it. Perfect timing, because part B says use Euler's method. This is kind of a weird problem because A, B, and C is all A-B stuff. Euler's method is a B-C topic. So they would omit that one and sort of readjust the points on that problem. So they could still give you that problem and just weight A, B, and C a little differently than they do for the B-C test. Back to that. So on your test, you will not have an Euler method question. And so you peek ahead on free response question number 4B. Use Euler's method. Nope, we don't do that. You can throw that one out. Or throw part B out, not the whole thing. And then I think there's one on the multiple choice section, the very first one. Euler's method, that's BC. You can throw that one out. But the rest you can do. All right. So your assignment this week is this worksheet. So that's free response, topic 5, multiple choice, topic 7, even though those are both the same topic. And then the videos, 2 videos this week, videos 4 and 5.